And it might be a show of kindness to photograph this at the end of the period so you can send it to your friends in Mexico. Maybe put it on some, is there a bad Snapchat community conversation of some sort? Media sharing platform of any sort? So the kid nobody likes isn't going to get it, man. Some way or another, I'd like to get this to our friends in MAD. Maybe somebody could photograph it and put it on our class Facebook group. So don't forget somebody the other day. We're going to talk a lot about this. This is assignment 7.3. I'll get like this far today, and then tomorrow this goes pretty fast. Or Thursday, that goes pretty fast. First, I want to go over the vocab in 7.3. Please take out your 7.3 notes. There's like one word that we need to really clearly distinguish. What? 7.4 was due today, 7.3 was the last one. I like to make sure that everybody in the room has their homework, so even if you didn't have it ready for the stamp, you've had a couple of other days to get it done for no stamp or to return to your absence or whatever. I mean, get to work.
I'm not hearing you, I'm sorry.
Figure, bro. So renewable, non-renewable is easy. I don't think I need to say anything, right? Renewable, non-renewable. Except that, what if you have a renewable energy source where the materials are non-renewable? Whoa. Like, we're never going to run out of wind because it's renewable. But what if the wind turbines were made out of rare metals that are not renewable? So the terminology is obvious, and I hope you're fine. Don't believe the hype when somebody tries to use just one of those words. Nothing is ever perfectly just, renewable, or not. You're wrong. You're allowed to ask, but that's also where I'm going. Biofuel is any living thing that you use to make energy. So methane from landfills, or lighting your farts, or lighting your head on fire are all biofuels. So is biodiesel, so is ethanol. Technically so are fossil fuels, they're just not recently bio, they're just a lot more fuel. So fossil fuels are really fossil biofuels. But digestion is the word I wanted to focus on. Breaking down chemical bonds to release their energy. And it is 3-star critical that you know the difference between aerobic and anaerobic. Especially if it applies to carbon compounds, organic compounds. You must write somewhere on your papers, this is like on every AP test. And coincidentally, it's just vocabulary used in passage, so if you don't catch it, you've missed a big marker. That when carbon compounds decompose near oxygen, you get CO2. And when carbon compounds decompose without oxygen, you get natural gases. Aerobic, with oxygen, CO2. Anaerobic, no oxygen, CH4. That's why you can light your farts, but you can't light your burps.
Is oxygen aerobic?
Aerobic is when you have air around. You need air
Wait,
for the oxygen.
aerobic is carbon compounds turned into gas without oxygen?
That's right, that's right, that's right. Anaerobic just means without oxygen. So you can do anaerobic exercise, right? Where you exercise to the point where you're breathing to keep up with your energy use. So you're an athlete, you know this, like when you start to get like that burn in your muscles, because you're not getting enough oxygen there, so they're using anaerobic decomposition and so they're making all kinds of crazy lactic acid, is that thing?
Yeah.
So then they do anaerobic exercise, right? When you go anaerobic, you get lactic acid.
Well, lactic acid is like what builds up when you exercise, and then when you like cool down after it gets really
Okay, so I think what happens there, if I have my biology 101s or any bio teachers around here, isn't there something about that?
Yeah.
What is it?
Basically your oxygen is being replaced by CO2, so your body turns into getting energy through anaerobic respiration, lactic acid, like a fermentation, essentially lactic acid fermentation, and then and she's exactly right. As you conserve your energy, then more oxygen is being replaced, is replacing the CO2 essentially.
And so the distinction that we need to make that might remind you through exercise or through what Stephanie said or through fart lighting, aerobic is air, is oxygen. In terms of carbon, that makes CO2. Anaerobic is not air, as in your intestines. In terms of carbon chemistry, it makes methane, natural gas. And just so you know, this is like a real world energy source that is gigantic. Think about a landfill. All that organic waste that you and I throw into our garbage, buried underground away from oxygen, is making gigantic volumes of methane. So Los Angeles gets something like 8% or 10% of their electricity from a power plant that's built on top of a landfill, where they capture the methane under, from the landfill, anaerobic decomposition. They trap all that methane, basically plastic and concrete until they get the funnel. They separate out the other stuff, and now that they've got all the methane, they run a huge power plant that gives Los Angeles a ton of electricity. My friend was on a hippie commune in Brazil, where everybody pooped into this one outhouse, and they had it plumbed all fancy, so it went into this special anaerobic decomposition tank, where the poop decomposed, all the methane was captured, and that's how they ran their cooking stove. It's not like fart smell, it's just methane. Our power plant, our wastewater plant captures all your food, do fancy plumbing to let it continue to decompose. It basically is what your gut was doing. They just keep going. Do 2.0. And they take a bunch of other organic material in our waste stream, like the stuff out of your food disposal and your laundry machine and stuff, and all that gets fed to poo bacteria, and they make methane that they use for a power plant at the wastewater facility. Ask me now. Before we get into these, I need to introduce one single clutch concept, a key concept in the sciences that you might remember from our class in previous weeks. I remember this thing, the magnet and the wires. Okay, here comes a slideshow that I once made about this. Here we go. Watch. When you move a magnet past a wire, you make current in the wire. EMF, electromagnetic fields. Some of you might know that there's like a specific direction, so when you move the magnet this way, the electricity goes that way. How many of you have heard that? Left-hand rule? There's two hands. There's the left-hand rule of induction to a wire, and then there's the right-hand rule about which way the electromagnetic field spins around a wire that's already carrying the charge. You know all this? Left-hand rule, right-hand rule? Is this in your science education?
Yeah, it's just in my dad really like another stuff. I think it might have been freshman year.
Got it. Feel free to forget it again. But I'm talking about that thing that you may have heard about once. And it works on a lot of wires. But now imagine, what if I could loop all those wires together? What if I could take the electricity from this wire and put it into this one, then put it into this one, then put it into that one? As a magnet, if I could connect all those. Well, you can, like that. And what you get is more electricity in the wire. And apparently it's not that difficult for people who know what they're talking about to figure out how much wire, how many magnets, how many spins of the wire past the magnet to make how much electricity. And this is essentially how we make almost all the electricity on the planet. Notice I said almost, and I'll come back to explain what the almost is about, but almost all of it is this. Find some way to spin the magnet past the wire or spin the wire past the magnet. Wires and magnets and magnets and wires and wires and magnets and magnets and wires. And really, all the different power plants, with one exception, all the different power plants are just trying to figure out how to spin that turbine. You can use flowing water, you can use currents in the ocean, you can gather tidal energy, you can gather waste energy, you can use heat from the sun, heat gained from sunlight, you can use heat from burning a variety of things. You can make a human-powered power plant where humans are spinning the turbine, or you could burn the humans to make a fire to make the steam to spin the turbine. Yeah.
So if you use like methane, for instance, how would that?
You boil water to make steam. Yeah.
What?
Yeah, methane lights on fire. It's natural gas type parts. So imagine lighting enough parts to boil water.
Oh,
And then that steam is pressurized in the butane system. Yeah. Like a tea kettle makes this whistling sound? So you just like put a little fan in front of it. Yeah, imagine, here it is, watch. Put some little paddles on this, hold it up to a tea kettle, and I've made a methane, and then the rest is efficiencies. Right? Yeah. That's the whole kit and caboodle for like 99% of the electricity on the planet. So you can spend all this time designing the blades and making different blades and bigger blades and fancier blades and mega blades, or put them underwater somehow, or use them to capture falling water, or use them to capture pressurized steam. You can use nuclear decay to heat the water to capture the steam. But all we're doing is finding some way to spin that turbine. And I always think it's interesting that there's like 38 trillion companies on the planet that make energy, but only 3 or 4 that make turbines. Like, they don't care. They're like, yeah, whatever, go ahead. Green technology nerds, you're still going to need magnets and wires. We call those things the turbine. Just so you know, it's going to show up a lot. I've drawn turbines all over the place. Watch. There's a turbine. There's a turbine. There's a turbine. Here's a turbine. There's a turbine. Turbine, 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 turbine. I didn't get to fit. Geothermal is going to go over here somewhere. It'll have a turbine. You might notice that there's no turbine right here, though. This is the exception. I want to show you, there's like 5 different parts of number 29. Okay, watch. Solar panels, how panels work in a house, this other kind of solar energy that most of you have never seen, and then another kind of solar energy that I think is even more cool. That takes a lot of time. This goes really fast. This is turbine, 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 turbine. I mean, they're sealed. So to break it, it's not waterproof. All right. We call them photovoltaic panels or PV panels. You got to know those terms. Photovoltaic or PV. Light into electricity. Photovoltaic. Photovoltaic panels have 3 parts. This is not the kind that you use to heat the water in your pool. This is not the one with plumbing on the inside for water to flow and get heated. This is the kind that makes electricity. The ones that make electricity, the kind of glittery, sometimes they have like a hint of blue. You speak the same language? Hint of blue? Those ones, they look like they have little patterns. Those have 3 layers, 1, 2, and 3. Silicon with boron, a semi-permeable electrolyte membrane, no big deal, and silicon layer. I'll come back. Silicon is not silicone. Silicone is like runny and it dries, it's kind of flexible. You can use silicone to like seal windows. It goes around your bathtub sometimes. Different kinds of silicone can make fake boobs, although not so much anymore. Silicone is like kind of gushy. Silicon is very rigid. At the molecular level, silicon lines up with other silicon atoms perfectly. So when you make a sheet of silicon, it is an extremely uniform foundation to do chemistry on and engineering on. So some of you might know that there's a place called Silicon Valley where they make a lot of fancy microchips. And the best way to make a fancy microchip is for all the little parts to line up. If not, your phone doesn't go ring or whatever. That's why they use silicon, because it makes perfectly uniform little grids. Have you got that so far? Please look up. Our sandwich has 2 silicon sheets with something in the middle, and I'll get to the middle at the end. The bottom one is just plain silicon. It's just a grid of that silicon stuff. And at the top, there's silicon with little impurities of boron, and you have to know that it's boron. By now, technically, high-tech solar panels have a lot of different stuff. But solar panel 101, like the solar panel of the 1980s, was all boron. So I'm teaching you the basic technology. When you go to university, you'll find out how they changed it from boron to other stuff. All right. That's what those are all B's for the boron. Remember when I said that big jumble of words in the middle? Semi-permeable electrolyte membrane? You absolutely positively have to know that. And it's complicated, and I'll explain it for like 5 minutes, and then I can go on. A membrane is a membrane is a membrane is a uniform layer. So there is a uniform layer in the middle there, that's the membrane part. The semi-permeable means it's permeable, but just kind of permeable. You all know what permeable means? What does permeable mean? What? Something can go through. So what would it be that it's semi-permeable? Something sometimes. People who are really uptight about the borders talk about how they're too permeable. And if you ever tried sneaking across the border, you realize they're not all that permeable. Or like maybe a couple of spots, maybe, but not that much. Semi-permeable is probably more fair. My house is semi-permeable. Like you can walk in through the door, and you might be able to push your way through the window, but you can't walk in through the roof. Semi-permeable. And does anybody know what electrolytes are? You all know them in one sense. What are they in your diet? What are the electrolytes in your diet? What? Not exactly.
Will give you drink electrolytes.
That's kind of how we brand Gatorade, but that's not true.
Not true.
What?
Not true.
No. I mean, well, technically, well, it gives you a great sugar high, because Gatorade has a ton of sugar, and that is energy.
But what about
It's not the electrolytes.
smart one?
Also not true. It doesn't give you energy, that's true. Anybody know what electrolytes are? What are they?
You know, like how we stay hydrated by holding water in your body?
How?
Is salt retains water? I don't know.
Kind of. Electrolytes are things that have a charge. You all know that sodium and chlorine are both charged, and so they make NaCl, salt, that get together because they're little magnets, ionic charges, ionic bonding. Y'all know that? Ionic bonding, ions, charges? Yeah. Electrolytes are charged. So the reason that you drink Gatorade is because your nervous system needs charged particles to send signals to communicate. So you start kind of bonking because your muscles can't do their stuff and you have some electrolytes and that helps you. Funny thing is that, just like, you want to talk about electrolytes or Gatorade? Gatorade's a total scam. So smart water. You would have to be right on the edge of dying for it to help you. No offense, chances are you've never been there. Unless you've had like really extreme diarrhea with barfing, or like you can't drink water, like if you've had like dysentery, norovirus, like super serious life-threatening diarrhea, then they give you electrolyte solution. Or if you're literally at the ragged ends of endurance. So when you're like running your 4th marathon of the day, and you're starting to pee blood because you're like metabolizing stuff that's not meant to be metabolized, that's when you really need the electrolytes. So you see a professional athlete, like truth is that a professional athlete, like right at the end of the game, they could use a little hit of electrolytes, maybe. But the way that they can get their electrolytes is literally to take like a pinch of salt and put it in the water and just drink that. That's what smart water is, just salt water. You can make your own smart water. You'll get water and then put a little bit of salt, table salt. You're good. Well, it makes some people a ton of money. That's a very important part of our world. But you don't need to pay for it. It doesn't do you anything except gives you, in the case of Gatorade and stuff, a bunch of food coloring that are debatably good or bad for you, and a bunch of sugar that we know is very bad for you. So, most of like the energy hit that you feel is a little sugar maintenance. So like a lot of marathon runners will carry gummy bears in their pocket for the same purpose. Like a little bit of sugar is a really good like little energy burn. Like when you're already burning at high octane, when your body's like really running, you take a little bit of sugar. It feels great when you get back to work. Any endurance sport, you need a little bit of sugar. Back to me though. Electrolytes are charged molecules, and so it's semi-permeable depending on the charge. That's the whole point. If I wasn't so stupid and lazy, I might have hopped on the train to be a zillionaire today by designing more semi-permeable membranes. There are people my age who have like the private helicopter to the private yacht to the private island because they designed really fancy semi-permeable electrolyte membranes. They're called SEMs. They designed really fancy SEMs. I have no idea how they do this. It's got something to do with nerdiness and voodoo. But if you've got the right situation, you can make a semi-permeable membrane that only lets extreme charges go through, or that only lets certain charges go one direction or the other, plus this way, negative that way, or negative this way, and or just one of those, like only a one-way street, only for negative charges, or whatever. And there's like a lot of electronics in our modern life, and so semi-permeable membranes have become like a really big deal in the electronics world. There's a lot of really cool engineering going on because of nerds that can do that. I have no idea how to do that. I ain't got no private eyes or no private yacht. And you have to know that in this one, I even drew it for you, negative charges only and go down only. See? Down for negative. That's what this particular membrane is. There's different membranes. If you build a solar panel upside down, it doesn't work. It only works when the negative goes down. So you notice how I drew it, kind of like a funnel to the bottom? That's very specific. See how like those little doors are like pointing from the boron layer down? That's on purpose. And I don't know how many of you speak chemistry, but boron is right there, and if you know how to read the periodic table, you know it has one valence electron that's very loosely attached. See what boron is? So that's why we use boron. Please look up. Because boron, when excited by sunlight, will lose control temporarily of one of its electrons. Anybody know what charge electrons have? Negative? And so which way will they go in the solar panel? Down. To layer number 1, 2, 3. So all those electrons, they peel off the boron and they migrate to the bottom. And anybody know what charge that creates on the bottom layer? That pole right there, what charge does it have now that it's flooded with electrons? What? This pole right there, what charge does it have below with electrons? Negative charge, a whole bunch of electrons. Anybody know what happens to this pole now that you've subtracted a whole bunch of negatives? You've left behind a positive charge? And I don't know if you speak battery, but I just built a battery. You know, negative and positive. Potential to do work. Everybody knows that opposites attract, and those negatives are going to try to go back to positive. So if I connect those things with a wire and I build a circuit, I'll turn on my light, and as long as the sunlight is hitting, that boron is too excited to hold the electrons, and that one-way street keeps pushing them through to that side, maintaining that polarity. So as long as the sunlight is out, I can run that light bulb. And when somebody shuts off the sun, those borons, they get less excited, and basically all these electrons go back home, so to speak. And the electrons have all gone back home, then we're out of electricity, and the lights go out for the day. And so the next time somebody turns on the sun. Yeah? We'll get to that. We'll get there, probably tomorrow. Some today, some tomorrow. There's a lot of ways to store energy. We're going to talk more about this. Yeah, bro?
So, does it always have to be semi-permeable?
Yeah, it does. Because if it's truly permeable, it's nothing. Like water is a permeable electrolyte membrane. Water can carry all charges, positives, negatives. What makes these fancy is that they are, you can also call it selectively permeable. That might be better. If that helps you, that's fine. The concept is that selectivity, that it only allows a certain charge to go one way. So if the boron's on top and sunlight hits it, right? Then you're going to have all these extra electrons around loose from the boron. And because the electrons are negative, they'll move through, but nothing else will. So you create polarity between the layers because that thing's in the middle. Now, anybody want to ask me anything else about how the panel works? I just kind of glanced over it, but nowadays we have really fancy panels. It's not just boron. It's not just silicon. You can talk to Ms. Woods. She actually did a bunch of nerdiness in some labs that are working on solar panels. And coincidentally, UCSB has a Nobel-winning physicist that works on solar panels. So you're kind of in the right place to ask the question. We've asked the wrong guy because I just told you everything I know. All right. So you can do two things. You can run these off-grid or on-grid. Watch this, I'm going to go fast. Off-grid is when the solar panels charge a bank of batteries, and then you let the juice out of the batteries to make your sunlight. Off-grid, batteries. And I don't know if everybody realizes that batteries are not a perfect storage of energy because of transformation of energy. You understand second law of thermodynamics? Whenever you change form, you're going to lose some quality. So batteries take some of the electricity coming in, they make it into chemical potential, then later on, when you let the chemical potential out, you get some electricity out. But batteries suck. The best batteries in the world are maybe flirting with 35% efficiency. Most batteries are way less than that. Your car batteries, you're putting in 100 units of electricity and you're lucky to get 15 units of electricity out. That's not very efficient. In other words, please look up. If I'm making 100 units here, I'm getting about 20 units there, maximum, 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 maximum. And that's all downhill as the batteries get older and the wires get older and the panels get older. So, off-grid, it sucks. It's inefficient. It's also expensive. If you need 100, you've got to have the capacity to make like 2,000 or whatever. So it's expensive, and you got to maintain every part of the system. You only use this as a last resort when you absolutely have to. A fire lookout in the mountains, a hippie commune in the middle of nowhere, a sailboat where there's no other way to generate electricity reliably. This was solar power in the 1970s. I've got a book about how to build your solar home, and it talks about how to get all quirky with the batteries, and like, it makes no sense. You just set up a couple power poles and like bring electricity, whatever. You look at the numbers to be truly off the grid for electricity, and like, but anybody seen solar panels in their neighborhood? Like on houses, like around where you are? Those are all this. It's called on-grid storage, and here's how that works. Sunlight makes electricity that you put onto the grid. You have an electrical meter, and watch me. When you're using electricity, it goes this way, and then when you're generating electricity for your neighbors, it goes the other way. You spin the meter backwards, you reverse it. They're like, you owe me $1, you owe me $2, you owe me $3, and then it's like, wait, I'm making electricity. You owe us $2, you owe us $1, we're even. We owe you $1, we owe you $2. And then the sunlight goes out, and then you go back to, oh, you got it. Does that make sense? Which part? How can I help you?
Why would you owe them money?
Because you're getting electricity to the grid. Like all those wires, electricity flows 2 ways.
Oh, so like,
If they've got more electricity than your house, you're paying. But what if your solar panels are making it and you don't need it? Then you've got more electricity than the grid, they're paying you for it. Because you're a power plant now.
So it's just between two neighbors?
It's on the grid. So the first person that's using electricity, they take it from you. So during the day, you're running all the refrigerators in the neighborhood. Then at night, some coal-burning power plant somewhere else is running your fridge because there's no sunlight for it. Here's the big difference though. When your solar panels are running the neighbor's fridge, his fridge is pretty close. So it's super efficient, right? You're going from production to usage with very little wire. Think about it, the rest of the time they're using a coal-burning power plant in the Mojave Desert, you've lost 30% of generation and then 30% in shipping or whatever. Yeah.
So how would they give money? Like if you had a.
You get credit.
so like, they're like electric.
In the summer months, your power bill says this is not a bill do not pay. And instead of saying you owe us $38, it has brackets and it says your credit is $10 this month. So in the summer month, they owe you, and so they're like, dude, we'll pay you back, we'll pay you back. And then in the winter, when you can't make a lot,
You use that credit.
you use your credit, that's right. Yeah,
Why are they not available everywhere?
because not all the meters spin backwards. That's a fancy meter. When I lived at West Camino Cielo, I had a shady electrical system. At least I'm not broadcasting this on the internet. And my electrical system had an old crappy box. And I couldn't change it because it wasn't exactly official. I didn't want anybody to look at my power panel. So I have an old school meter that only spins one way. It would catch on fire if I tried to plug in solar panels. Meter, modern meter. Smart meters do this, but it's not. It's just a more, I don't know, bro. It's like a two-way meter maybe.
So, how come not everyone uses the on
Well, you got to put a lot of money up front to build that whole thing. You're spending $30 in electricity up front, or 30 years in electricity up front, or 20 years in electricity up front, or 10 years in electricity up front, hoping that it'll pay off. There's all kinds of logistic issues too. Like, your roof has to be a certain angle, facing a certain direction, you got to be a certain latitude with certain sunlight days. So some parts of the country are just too foggy, and some parts of Santa Barbara, your house faces the wrong direction. And some latitudes, like if you go too far north and south, there's just not enough sunlight on average throughout the year. Solar panels are kind of expensive, so right now with the state subsidies and everything, we can kind of pull it off. But right now, electricity is so cheap that like it doesn't really make sense. It runs out of juice before it pays for itself. But that's only because today we're not paying the real price of electricity. Keep in mind, I have a credit card and all the bills are going to your house. I just keep on spending, I don't have to pay these bills. Because today our economy is based on electricity and energy, where the costs are in the future. Your generation deals with climate change. Yeah, I'm going to Coachella and you're picking up the bill. You feel me? That's actually like metaphoric but accurate. I live in an economy where the cost is not captured. Carbon has expenses that we're not paying. You're going to pay. And they're all going to come to you at once. So your generation has to pay for 150 years of carbon plus your carbon. You feel me? It's a really good credit card deal. At that point, when electricity has a real cost, then solar panels really do pay off. But we haven't counted. So like a lot of people argue, like, in California, we're trying to drive down carbon. So in California, we're like, bro, just take them. And the state pays you to put these in. The state will pay like a third, a half of your system. Because California's like, yeah, we're going to have to pay for the carbon sooner or later. Let's just pay now. And in that economy, we're already going to bring the savings to the long term. Just so you know, these are awesome. They're super efficient. They're cheap, maybe even profitable. When we make fancier solar panels, when we make better wires, when we make better electronics to run the whole rig, that's actually really doable. But I gotta go. Look. Anybody driven to the Big Island of Hawaii? Driven. No, you haven't! Did anybody fly into the Big Island of Hawaii? When you land on Kona, in the Kona airport, like, you approach over the wet side of the island, you go like past Mauna Loa, whatever, the big volcano in the north, and then when you come in, like, the plane always turns like this, and you're looking off that point where the manta rays swim. You're looking off that point, and when you look over the right wing, you're looking down at this huge field of solar panels. It's surrounded by chain link, and there's all these like perfect rows of shiny panels. And everybody thinks that they're solar panels, but they're not. They're parabolic mirrors that focus sunlight on a pipe filled with hot stuff like oil and salt. And they can take that hot stuff and move it somewhere else where they make steam to spin a turbine to make electricity that goes to the grid. It's called solar thermal, where you use the sunlight to make the heat. If you want to make some notes, go ahead and make some notes. The secret is you can move the heat somewhere else to make steam.
Those mirrors ever like hit planes and blind them?
Their focal point is very narrow.
Okay.
So anybody here want to admit to using a magnifying glass to burning ants?
Not ants, but leaves.
It took you a minute. Just so you all know, Erica went and looked around like, is it just me because I'm not going to mess up to these? Erica's got secrets, kids. I see these things in front of the room. The same way that you can use a magnifying glass to focus light on a point, you can reshape that glass to focus light inside the parabola. And if you aim it to follow the sun, there's like little gyros that spin that thing. You just capture all that sunlight at one point, make a lot of heat, and you can use that heat to spin a turbine. But that's old school. A lot of mirrors, long distances, you don't get very hot. Check out the new school. It's called large scale solar thermal, and it works like this. A field of mirrors focuses light on the top of a tower. All those mirrors are hitting that tip of the tower, that brilliant white rectangle, like this. Please look up. It's mega large scale, big ass tower, acres and acres and acres and acres of mirrors that are all moving at the same time. Fancy little robot computer motors, geometry, science. And they track the sun to keep the tip of that tower at like 3,000 degrees. And instead of having like 10 miles of 2-inch pipe, you've got like 60 feet of like a solid glob of salt that gets to like 3,000 degrees before it gets running. Now hold on a second. Give me 30 seconds. It's just nutrition break. Watch this. We know how to store heat. So imagine a very, very, very thermos under that tower. You can keep it at 3,000, 2,500, 2,000, 1,500, 500 degrees for a couple of days. Now you can make sunlight into electricity in the middle of the night, during a shady storm. As long as you get sun every 2 or 3 days, you just build up some heat and then keep it in the bank. Then you let that hot stuff go through the thing and make the steam to spin the turbines. Just so you know, this is like almost borderline a maybe. This is like getting to maybe kind of possible sort of a little bit. There's 3 of these on the way to Las Vegas. They're right on the California side of the border. When you're getting ready to cross the border and there's Fake Vegas, that gas station that announces the border into Nevada. Anybody been there? You know what I'm talking about? There's like a fake border, but there's a real border. There's a Fake Vegas. That Fake Vegas, right when you can see the Fake Vegas below you, look to the left and there's 3 of these. I'm excited about this. Okay, evaporate birds. Yeah, keep the birds away. Okay, bye children.
That's really, the birds just like literally disintegrate.
I mean, I haven't seen it with my own eyes, but that's what I hear.
I feel like